Hey, AB Calculus, it's Mr. Canfield. Today we look at chapter 27, part 2, number 2. funny story, 27 only has 3 problems. We did 1 last time, we're doing 2 this time, and we'll do 3 this time too. Okay, so we're going to use properties of integrals, and if you don't know what that is, go watch the last video. Come on, I'm not rehashing what I just did, to do these problems. And they range from like stupid easy to really make you think. So let's look at our first one. First one says go from -2 to 5 and take the integral of f of x plus g of x. It is this easy. F of x from -2 to 5 is 18. G of x from -2 to 5 is 5. 18 plus 5 is 23. All right. Cool, and that's about the difficulty level we can expect for all these problems, right? I mean, look at this one. It says f of x minus g of x minus, wait, we know what each of those is. If you're like, wow, what's the big deal? This had to be proven that we're able to do this. So we essentially are, double negative there, so plus 11. So it's 29 minus 24, yeah, 24. If I got that wrong, I'm sorry. 13, yeah, that should be right, okay. This isn't for free, this was proven, but now we just use it for free. We take it for granted. All right, this one, we're going from 5 to -2. None of these go from 5 to -2. Oh yeah, I can reverse the bounds. -2 to 5, throw a negative out front. Well, there's a 4 inside there as well. I can pull the 4 out front, So I can pull the 4 out front, reverse the bounds, throw a negative out front. Now this is true. It's the same thing. -4 times from -2 to 5 g of x, that's 5. So -4 times 5 is -20. All right. Kind of wish I'd printed 2 copies of this so I can leave. Oh, you know what I can do? You know what I can do? Do you know what I can do? Can't find scissors. I do have one of these. Sorry about the movement. All right. Just make sure the blade is fully retracted. Oh, come on. It's like 9/10 of the way there. Don't want to leave any exposed pointiness or Sharpie sharps. That's good, good life advice in general. Also, I need to mention, I have a Band-Aid on. I had that on before I did this, okay? Oh dear, all right, I am putting this in a safe location. It is not cooperating, and you don't need me to waste more of your time with that. Okay, so let's see. Moving on to number D. All right, this is where it starts to get tricky. People look at this, and your gut reaction, if your gut reaction is what a lot of people's is wrong. It's not 7. Because what we've been doing the whole time is not just adding stuff together. We've actually been taking integrals separately and then adding them together. So in D, it's actually saying, did I say that smug enough? It's actually saying, take the integral from -2 to 5 g of x dx plus the integral from -2 to 5 2 dx. There, that was smug enough. So it's actually saying this integral, which we do know is 5, it tells us, plus this integral, which we have to calculate. It's not just 2. So this is where we'll have to take the antiderivative of 2 and evaluate it. So that's going to be 2x evaluated from -2 to 5. So when I plug in 5, I get 10. When I plug in 2, I get -4. So that's 5 plus 14, which ends up being 19. Why did I put a dot there? I don't know. Okay. So this is, it's one of those finer details questions that we're going to be seeing moving forward, just to really test to see if we understand what's happening with an integral. So, like with this one, it's very similar, right? We're going to go from -2 to 5 with f of x, and so that's going to be 18, but then it's going to be subtracting the integral of 6. And so that's going to be 6x evaluated from -2 to 5. Remember, I'm just taking the antiderivative of 6, which I took the derivative of 6x to get 6. Let's see. So that's going to be, so 6x, so that's going to be 30 minus -12, so plus 12. So I got 42, 18 minus 42. Let's see, 20 minus 42 would be -22. And then we're 2 less than that, -24? Nope, there's no way that's right. All right. Oh, it is right, okay. Right, because we got to borrow 1, get a 3 there, get a 12 there, yeah. Okay. Let's see. So our next one, when we break it up, we're going from -2 to 5, 1/2 h of x dx plus -2 to 5, 5 dx. So pull the half out front, and then we know that h of x is -11. So it's -11 over 2, because it's a half times -11. Plus, let's see, that's going to be 5x, right? So it's going to be 25 minus -10, or plus 10, equals I don't care. All right, so let's keep going. No, all right, fine, I'll do it. So this is 35, and if I gotta get them both over 2, 35 halves, nope, sorry, 35 I gotta do 2 over 2, right? So that's 70 halves. So -11 halves plus 70 halves, that should be 59. Yeah, 59 halves. Oof, oof, all right. All right, now moving on, go from 0 to 7. 0 to 7, h of x minus 2. I don't have 0 to 7. What? So this is a callback to pre-calc, or algebra 2, or algebra 1. Really depends on when you learned it. Like, well, that would mean what I just said. That's not what I meant to say. Depending on what year stuff got rolled out, you might have learned this in a different course. You definitely saw this in pre-calc, though. This is a transformation, a translation. H of x minus 2 is equivalent to h of x if we move it 2 to the right. So this is what h of x would be moved 2 to the right. All right, how do I explain this? Because it's easy. This is identical to taking 2 away from both of those and just dealing with regular h of x. Let me draw you a picture, though. All right, now let me draw a graph that goes along with this. So, like, let's say this was h of x, right? If I said, well, what is h of x minus 2? I would literally take this shape, and every single point in this shape, like, let's say, all right. I would take each of these points, move them 2 to the right, and those new points would be what h of x minus 2 is. So if I'm trying to calculate an integral, well, this area and this area, like, the area for this one between, you know, -3 and 0, that's the same as this new one, but instead of being between -3 and 0, it's going to be between -1 and 2, right? Each of them gets moved up 2. So if I'm saying, hey, for this new one, I want from here to here, well, the old one, I'll just take 2 away and go from here to here. Therefore, therefore, -11. Same thing with this one, except it's, instead of being moved to the right 2, now it's being moved to the left 2. So this is equivalent to reverse that moving to the left 2, right? So we're going to add 2 to both of those, get 5, get -2. It's interesting that says -2, you do -2 to those. That says +2, you do +2 to those. That's pretty convenient. It's one of those rare things that probably won't ever see again, but it's true and it works. I got 5. All right, now we get, wait. We don't know this one, right? Because it got cut off, but this is -2 to 8. We only know -2 to 8, and we only know -2 to 5. So this is where we use the transitive property, right? This idea that, well, I do know -2 to 5 f of x dx, and I do know 5 to 8 f of x dx. Well, look at this. Wait, no, I don't. I want to know 5 to 8. But what does -2 to 5 and then 5 to 8 give us? It gives us -2 to 8 f of x dx, right? If you go from A to B and then from B to C, and you only stop there for a moment, you're really going from A to C. So, and hey, we know this. This is 18. This is 0. So if 18 plus that is 0, this is actually a baby algebra problem. 18 plus x is equal to 0. This is -18. So, yeah, there we go. Let's continue on. All right, let's see. For this one, 1 minus f of x from 8 to 5. Oh, well, okay. So there's a couple of ways that you can do this. Maybe the obvious first way would be to reverse the bounds and pull a negative out front. 5 to 8, f of x minus 1. Wait. That's not, sorry. I did 2 steps at once, made a baby mistake. All right, let's try again. Pull a negative out. 5 to 8, 1 minus f of x dx. And if you want, you can even distribute this negative, -1 positive x, or positive f of x. That's what I was thinking, and I skipped a step. So both of those are fine. Or you could legit just, well, here, hold on. So we're gonna have to do, so this will be 1x, right? Because it's a number. So that's gonna be 5 to 8 was -18 minus parentheses, plug in, so 8 minus -5. Oh, okay, so it's not gonna be plus this time, -5. So that's 3, so I got -21. Another way to do this is to just kind of keep it. And you can say, this is 1x, right? Plug in 5, plug in 8, that's the first part, minus 8 to 5 f of x dx. Well, what is 8 to 5 f of x dx but negative that, right? So -18. So this is going to be 18. So 5 minus 8 is -3, minus 18 is -21. So 2 sides of the same coin, 2 ways to do the same problem. Cool. All right, let's talk about our next one, K. All right, So we got to break this up, right? So we got this guy off in its own integral, go from 1 to 8, 3 dx. This one, oh, it's moved to the right 3. So I can go backwards 3 and say that this is negative 2 to 5 regular f of x dx, which is 18. And then we got to do this one on its own. So it's 3x, so 24, yeah, 24, because 3 times 8 is 24, minus 3, 21. All right, 18 plus 21, 39. All right, and then, whoa, fancy schmancy. So same idea, right? We can pull the 2 out front, go from 2 to 9, f of x minus 4 dx minus 2 to 9, 6 dx. So this is me 6x. It would have been nice if he had put like a 6x here or something like that, and because like whatever function this is, we just take the antiderivative of it. So let's see, this is gonna be 6x. Plug in the 9, you get 54. Plug in the 2, you get 12. It looks like a negative. It's not a negative. We're going to subtract whatever we get here, which is 42, so minus 42. And here, well, we just got to subtract 4 from both of those, so negative 2 to 5, 18, right? So 36. 2 times 18 is 36. 36 minus 42, is that negative 6? All right, cool. So now let's look at the last part here. So this is the third question, right? Because there's only 3 questions on this whole thing. Evaluate the following by making a sketch of the function. Okay, so this is where we can use geometry instead of using our knowledge of calculus to, well, I mean, instead of using our knowledge of how to take integrals. So let's see. Well, x plus 2 is a line. It starts at 2, goes up 1 over 1, up 1 over 1, up 1 over 1. Yes, I do want to get every single dot that I can if I'm going to try to get an exact area. And I can keep going, but I'm only caring about from negative 3 to 3. So there we go. I'm trying to find this. Well, let's see here. For this one, that's 1/2. My base is 1. My height is negative 1. Oh, so the area here is negative 1/2. Then for this one, 3, 4, 5. My base is 5. My height is that 5? My height's 5. Okay. So it's 1/2 times 5 times 5, which is 25 over 2. So negative 1/2 plus 25 over 2 is 24 over 2, which is 12. Oh, but now it says, hey, this function here, take the absolute value of it. Well, hey, anytime a function is positive, absolute value does absolutely nothing. And when it's 0, it does absolutely nothing. But when it's negative, it flips it and makes it positive. So now, oh, hey. It's like the same, except that's a positive now. So positive 1/2 plus 25 over 2. So 26 over 2. Or 13. Then we have this. The absolute value of x plus 2. All right, well, first things first. Oh, and then the absolute value of it. All right, so this is a massive mess. I do know a couple of things, though. First thing I know is that x is like linear, right? When we plug in 0, we still get 2. And when x is positive, this stays positive. Everything's positive. When x is positive, nothing's different, right? So I already know here everything's the same. But now I need to figure out what the heck happens with negative numbers. So Well, with negative numbers, like if I plugged in -1 here, that's going to be the absolute value of -1 plus 2. And so if you let these things resolve correctly, or like in their own time, we do the inside absolute value first, it turns to +1. Oh, so it turns into like the whatever happened over here is going to happen over here now. If I tried -2, it would turn +2, and whatever happened over here happens over here. So it turns out that this essentially takes this and mirrors it. So if I wanted to find this area here, because that's what an integral finds, I don't need to do this plus this. I could just find this and double it, right? So this is a trapezoid, if you remember from last lesson, where the that was bad. Okay, looks like our bases are 2 and 5. Our height is 3. And so to find that area, we do 1/2 times the two bases added together. We're averaging the bases, and the height is 3. So that's going to be 21/2. At first, I was like, wait, that seems way bigger than this, and then I realized 21/2 is wait, yeah. Is that less? Did I make a mistake? Oh wait, that's one of them. There we go. 21/2 is one of them, but we have 2 of them, so I gotta do 2 times 21/2 and get 21. Because right, this should be bigger than this and this, because it's got the same part here, and then over here it's got more area, so it should be bigger. All right, final round. Well, they mixed it up. Okay. Well, I'm just going to plug in values. When I plug in 0, I know it's 2. When I plug in 1, it's 1. When I plug in 2, it's 0. And when I plug in 3, that's 2 minus 3, and it's regular 3, right? Because the negative's outside of the absolute value here. So it's -1, and then we take the absolute value and we get 1. So, and since everything's linear here, I know that there's not going to be any curvature. It's going to be straight lines the whole way. My guess is it's going to be like a W, but let's see what happens. If I plug in -1, it's the same, right? Yep, because -1 gives us the same as if we plugged in +1. -2 gives. So when I plug in all these negatives, it gives us the same as if we had plugged in a positive. So it's fair to say that it's a mirror. So if I'm trying to find this area, well, this first triangle, I have a base of 2 and a height of 2. So 1/2, 2, 2. 2's cancel, you get a 2. This is 1 and 1, so it's a half. And I have that, and I have that, and that's this. And then I have it again. So I could say 4 plus 1 or 5. Okay. Well, hopefully this was helpful. The homework is surprise, like very, very similar. So absolutely worth your time doing this practice. You know, it does, once you get it, it does get a little bit repetitive, but even those last ones are worth kind of thinking about. So, all right, bye.